David Smith here with one more Flip Classroom math video in the rain. 3 tips before we start. First, you can speed up or slow down the playback if that helps you digest the content. Second, you can pause the video anytime and catch up with your notes. Lastly, you could turn on the captions and watch my words go by on the bottom of the screen. Welcome to our first lesson dealing with geometric solids. So these are solid figures, and we're going to start off by just learning how to do some basic calculations inside the solids, and then we're going to calculate their volumes and their surface areas. So the concepts here are not super complicated, but some of the conceptualization of the calculations is tricky. So we're going to get started right here by just sketching a few of these types of solids. So for the first one, I'm going to have us sketch a cube. So a cube is just a solid that's got squares on all the sides. My favorite way of sketching a cube is make my square, do my slants, another slant, and like that, there's a cube. Now sometimes we want to see the inside, so we use dashed lines to represent the edges that we can't see. So that gives you a feeling for the cube. And then also we want to label stuff. So we might label the corners A, B, C, D, E, F, G, and H. And then finally we might put numbers on there to figure out, like, so you can actually do some calculations based on that. So let's say this cube has a side length of 5 centimeters, so I can put that right there. And that's all I need to do. If I know this is a cube, then I know every side in the diagram is 5. Now, what kinds of calculations might we do? Well, perhaps we want to calculate the diagonal across the bottom. That might be a calculation that we want to do. We might also want to calculate the angle from this corner all the way down to that corner on the back. It would be the angle between these two lines. And we'll get into things like that in a little bit. All right, so the next one is a triangular prism. Now, a prism is a figure that has a base and a top that's in some shape. In this case, it's going to be a triangle. And then it's got parallel sides that make it into a prism. Okay, let's draw a triangular prism. So my first step here is I'm going to draw my base like so. And then I'll make my vertical lines go up. And then my top. And so we're looking at this, we're looking at it bottom on. And so there is a back line that we don't see. So we're looking kind of up at that. My triangular bases are here, and then my lateral sides are there. So one of the calculations that we'll do for a figure like this is we'll find the area of the bases, and then we'll find the area of the lateral faces, and all of those areas together make the surface area of that prism. All right, let's get into some calculations here. First off, I want to draw your attention to these 2 words. A cube is like we drew before. A cube has square faces, so there's really only one measurement. That's the width of a face or the height of a face, just one measurement. A cuboid is kind of like a cube, but the sides can all be different. Another word for a cuboid is a rectangular box. So I've sketched one here where I have my base here, and you can see that the front side here is 5 centimeters, going back is 4, and then the height is 6. Okay, so that's a cuboid or a rectangular box. And I've drawn the solid lines are the lines that are out, that are facing us, and the dashed lines are behind that we can't really see, but we draw them in the diagram because we need to know what's going on there to do our calculations. Okay, so find AG. So let's take a look at this, and we see here that AG is the line that goes from the back corner to the front opposite corner. So we're trying to find this line here, the length of that, going from there to there. I'm going to use red just so you can see that. Now, in a cuboid or a box, you have 90-degree angles everywhere. So that means you can use Pythagorean theorem and you can use SOHCAHTOA trigonometry to find stuff. So to find AG, we don't have enough information. We do know GC, that's the 6, that's the same as this one. So I can label that. But I still need a little bit more. I'm going to need AC here, because then I have a right angle right there. So that would allow me to use the Pythagorean theorem on this triangle. So I'm going to go ahead and do that. So AC is pretty easy. I'm going to write it in here. First, find AC. That's going to give me my, my other side that then I can use Pythagorean theorem with 6 and whatever that is to find that. Now I find it's really helpful to take a diagram out of the complicated 3D diagram and boil it down so you're sure you do the right calculation. Now notice that this is a right angle there, so I'm going to draw that triangle like so. This is DAC. AC I don't know, but AD, this one here, that's going to be the same as the 4. These two sides are the same, so that's a 4. And then this one is my 5, my DC is 5. And so AC squared is going to equal 4 squared plus 5 squared. Do you see that? I'm just using Pythagorean theorem. So then AC itself is going to be the square root of 4 squared plus 5 squared. Go ahead, pause the video, do that calc. All right, let's see how you did. I ended up with AC equaling root 41, which is approximately 6.40. Let's mark that on our diagram. We might need it later. 6.4, right there. Okay, so now that I've found my AC, I have what I need to go ahead and find my AG, this interior diagonal of our cuboid. So again, let's sketch that. My triangle is going to be ACG with the right angle right there between A and G. So I'm going to go ahead and just draw that out like this. And I have my right angle at C. Here's my A, and here's my G. And A is 6 from the diagram there. This is our 6.4, but I'm going to go ahead and put root 41 back in there, because guess what? When we solve for AG, we're going to square it. So here's my equation. AG, by Pythagorean theorem, AG squared is going to equal root 41 squared plus 6 squared. So go ahead and pause the video and find AG. All right, let's see how you did. I got it equals root 77, which is approximately 8.77. So there you go. Let's figure out another thing that we can learn about our cuboid. All right, let's find an angle. Let's find angle CAG. So back to my diagram, angle CAG is going to be this one right there. Now I'm going to go ahead and draw my little triangle just so I make sure I get this right. I have angle C, which is my 90. Here's my A, and here's my G. And so I'm trying to find this one. I'm going to go ahead and call it theta. We don't have to, but we can do that. And check it out. I'm going to use, I have my 6 from here. That's my CG. And I have my AC is 6.4. Now I happen to know the hypotenuse. This is 8.77. So that's really going to free me up to use any of the 3 trig ratios. But let's just do it with this. So pause the video, use these 2 sides to find theta. 43.2 degrees is what I get for that one. All right, let's do some more calculations. This time, we're going to use a rectangular pyramid, okay? So I've drawn that in here. Rectangular is the name of the base, and a pyramid just means all the corners go straight up to the top, okay? So a square pyramid would have a square as a base. This one's a rectangular pyramid because one side is 8 centimeters, the other side is 5 centimeters. We've labeled our base A, B, C, D, and then our top is E. And it's also telling us that we have a vertical height of 10. So I'm going to go ahead and sketch that in. That is 10. So that's a straight line dropping down from the tip of the pyramid to the center of the base. So that's our vertical height. Now, what might we want to calculate? Let's take a look. Find the angle between base ABCD and edge BE. So let's sketch some stuff on there. Here's edge BE. It's from this corner all the way up to the top. I'm just going to dash that in. Now the angle between that and the base is flat. We could calculate that anywhere, but we need to do it in a certain spot because we need to use the 10 when we go for that. So I'm going to put a little dash there and this is my right angle. Okay? So far, I can draw this triangle now. Let's label it. So, let's call this point O for origin or orange, I don't know. Something. That's O. That has our right angle. Here's our base out here. That's B. And then we have our E up on top. And we're wanting to know this angle. That is the angle between the edge, BE, and the base, which is represented in this 2D diagram by OB. And I want to emphasize, 3D diagrams can be confusing, so it's always a good step to figure out what you're doing for the certain calculation and peel out and do a two-dimensional drawing for that before you do your calc. So I'm going to go ahead and mark this angle with theta, just to keep me focused on what I'm trying to calculate. And then I can mark this side as 10, because that's my height from O to the top of our pyramid. So I need to find this angle. So I have two roots. Two roots. I could find this length, and then I could use trig, or I could find this length, and I can use trig. And it turns out that finding OB is going to be the easier way to do it. So I want you to look at that diagram, and pause the video, and see if you can figure out how we would find OB. Okay, so let's explain a little bit, and then I'm going to turn you loose on the calculation. So the first step is find OB. So OB is half the way across. Remember how we said O is in the center? So we could calculate DB and divide that by 2, and that would give us OB. And that's going to be nice because we know this is a rectangular base, so all the corners are right angles. So we can find DB by using Pythagorean theorem and AB and AD. So I'm going to go ahead and sketch that 2D diagram right here. We have our 5 and our 8. This would be A, this would be B, and this would be D. Okay? So DB is going to be found with Pythagorean theorem with this. So let's just do that. DB squared equals 5 squared plus 8 squared. So go ahead and pause the video and do that calculation. All right? So now I got that. Let's see if you got it. DB is the square root of 5 squared plus 8 squared, which is the root of 89, which is 9.43. So do we have what we need now to do this calculation? You tell me. Not quite yet. We found DB, but O is exactly in the middle of the base, so OB is going to be half of DB. So OB equals root 89 over 2. Go ahead and do that calc. All right, so now we know what OB is. I'm going to go ahead and label it on my diagram. OB right there is 4.72. All right, so now we have enough to satisfy this request. Find the angle between the side BE and the base of our pyramid. So go ahead and pause the video, set up your trig equation, solve it, and then tell me what you got for theta. Okay, let's see how you did. So my function that I'm going to use is tangent, because here's the angle I want, and the sides I know that help me find it are my opposite and my adjacent. So that's tangent, the TOA from SOHCAHTOA. And then I did my inverse trig of opposite over adjacent, 10 over 4.72. That gives me theta. I put that in my calculator and I got 64.7 degrees. So these two examples so far have shown you that you're going to get asked to find things in these complicated 3D diagrams, and you're going to have to figure out what steps you need to do to find them. Most of these problems aren't going to be just one thing, find it. You're going to have to find one or two or maybe even 3 or 4 other things that then together you use that information to find the thing that they're after. So definitely critical thinking steps in here, and 3D spatial thinking. So some of you are really good at that. You just can visualize things in 3D, and that's going to be really helpful. If you're not in that category, I really strongly suggest that you figure out how to make the sub-diagrams, that you maybe draw the picture in your notes, use colored pencils to emphasize the parts. Like you could even shade like this triangle, that's this triangle that really was where we needed to go. We just had to take a side journey to find that length so that we could then find theta. So just keep all that in mind. Thanks for watching. Just before you go, make sure to write down any questions that you have so that you can bring them to our next class and get them answered. Also, remember that you can watch the video again if you want to deepen your understanding. Finally, if you enjoyed the video, please click like or subscribe.